Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others who want to test their math skills with these types of test questions. And this will be our 31st part in this math skill series. And what we have going on here is that we have to perform the following integral of 0 to pi over 2 of cosine to the 15th of x multiplied by sine cubed x dx. Alrighty, so this integration looks really nasty, but if you do the proper substitution at the correct time, this actually comes out to be very, very simple. So let's work on getting this a little bit easier to work with so we can make a substitution. So what I'm going to do is I'm going to start with a trig identity of sine squared of x plus cosine squared of x is equal to 1. And what I'm going to do is I'm going to rewrite that in terms of sine squared x is equal to 1 minus cosine squared of x. Well, let's work with the sine cubed portion over here. Sine cubed of x is essentially just sine x multiplied by sine squared of x. So I'm just going to take this portion right here and dump it right into there for sine cubed, or for sine squared. So sine cubed x essentially is just sine x multiplied by 1 minus cosine squared x. Well, I'm going to take this and I'm going to plug it in for my sine cubed over here. So what does that give me then if I rewrite this? So my integration becomes 0 to pi over 2 of cosine to the 15th x multiplied by, well, sine x times 1 minus cosine squared of x dx. And not much more simpler now. It didn't really help much. Well, it will. So what I'm going to do now is I'm going to take this portion right here of cosine 15 of x times the sine of x, and I'm going to dump it into each portion here. So I'm basically going to multiply through. So this then becomes 0 to pi over 2 cosine to the 15th x times sine of x, subtracting off, well, now it becomes cosine to the 17th x multiplied by sine x dx. And it didn't really help much either, did it? No. Well, it will. So what I'm going to do, since I have this minus sign right here and I have two separate terms, I'm just going to break this up into two integrals here. So I need my limits here of 0 to pi over 2, and then I need to put a dx with my first one because the second one already has a dx. Alrighty, so now I have two portions. So how does this make this any easier? Well, this is where we're going to do our substitution. So what I'm going to do is I'm going to let u be equal to cosine of x. Well, that means for the derivatives of this, du will be minus sine x dx, because cosine of x turns into a minus sine x dx. Well, take the minus sign, flip it over here to the du. So I have minus du is equal to sine x dx. Well, do you see what we have going on here? Well, sine x dx, well, there's sine x dx. Well, that would just be minus du. And then I have u equals cosine of x. Well, there's u to the 17th power, and then there's u to the 15th power. But before I actually plug in u and du into here, because I have limits of 0 to pi over 2 and I'm using substitution, I have to adjust to new limits. And this is a part that a lot of people forget about, is that you have to also adjust your limits. So u at 0 will be equal to what cosine of 0 is equal to, and that's just equal to 1. And then the upper limit of u of pi over 2 is equal to cosine of pi over 2, which is equal to 0. So let's substitute everything in here and put in our new limits. And what we have is that we will have u is equal to the lower limit of 0, so that'd be 1, and then pi over 2, well, pi over 2 pops out to be 0, and it'll be u to the 15th multiplied by minus d, or not multiplied by, but minus du, and then subtracting off 1 to 0, the same limits here, of u to the 17th of minus du there. So let's take out our minus signs from the du for each portion here. And this will become minus 1 to 0 of u to the 15th du. And then plus, because minus with the minus becomes plus, 1 to the 0 of u to the 17th du. And isn't that a much nicer integration for both of these portions to do? Better than what was up here with cosine 15th x times sine of x. So integrate both of these and we end up with minus u to the 16th over 16 from 1 to 0 plus u to the 18th over 18 from 1 to 0. Now, technically you would have an integration constant here of c, but it doesn't really matter with a definite integral because, well, it would cancel out in the subtraction when you're evaluating these limits of 1 to 0. So this is the proper way to write it. So let's go ahead and evaluate this. So we would end up with a minus, well, it would be 0 to the 16th over 16 minus 1 to the 16th over 16. And then plus, well, once again, 0 to the 18th over 18 minus off 1 to the 18th over 18. And essentially we end up with 1 over 16 from the first portion. The minus becomes a plus. And then subtracting off 1 over 18. And essentially this entire integration boils down to 1 over 44 as our final answer. So this nasty looking integral at the start of cosine 15x times sine cubed x dx with those limits boils down to 1 over 44 as your final answer. So I hope you enjoyed this video, and I hope you learned a new math skill from it along the way. And if you want to test your abilities even further, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us greatly over here. Thank you for watching, and I hope you have a fantastic day.